Lesson 1. Thermodynamics and the Brayton cycle. Welcome to the foundations of gas turbine engines. To understand how these engines work, we first need to look at the continuous process they use, known as the constant pressure Brayton cycle, or Joule cycle. Unlike a four-stroke piston engine, which performs intake, compression, combustion, and exhaust intermittently in a single cylinder, a gas turbine performs all four of these processes continuously and simultaneously in separate, dedicated components. When air enters the combustor and is heated at a constant pressure, its behavior is governed by Charles's law. This law dictates that at a constant pressure, the volume of a gas is directly proportional to its absolute temperature in Kelvin. For example, if air enters a combustor at 500 Kelvin and is heated to 1500 Kelvin, its specific volume increases by a factor of 3. We can also calculate the ideal thermal efficiency of this Brayton cycle using the ratio of specific heats, which is 1.4 for air, and the engine's overall compressor pressure ratio. When all that expanded air is finally pushed out of the engine, it demonstrates Newton's third law of motion. By accelerating a high mass flow of air rearward, the engine creates a forward reaction force, or thrust, that is equal in magnitude to the rate of change of momentum of the exhaust gases. In the next lesson, we will explore how we compress that air in the first place, before it even reaches the combustion chamber.